On May 18th, 1980, a catastrophic geologic event occurred that not only shocked the world because of its explosive power, but it also challenged evolution theory at its foundation. That event was the eruption of Mount St. Helens in 1980 in Washington State. I believe that the eruption of Mount St. Helens will be remembered as one of the most significant geologic events of our century. And when people look back on the 20th century and ask what was going on geologically to challenge the dogmatic teaching of evolution in our day, I believe one event is certain to come to people's attention, the eruption of Mount St. Helens. There in Washington State in 1980, in a very real and graphic way, a miniature laboratory was set up for the study of creation and catastrophe theory. In the next few minutes, I'd like to explain a little bit about what the volcanic eruption was like, relive the event by way of slides, the activity that we saw there, the photographic documentation, visit the places. We've overflown it with helicopters, that type of thing. Another thing I'd like you to know and understand is a little bit about what the volcano did in very short order. An incredible series of events was set up by this rather small volcanic eruption that challenge our way of thinking. And I'd like to apply what we have seen at Mount St. Helens and what you can see at Mount St. Helens to other geologic features of the Earth. Grand Canyon, Yellowstone, coal layers, that type of thing. Finally, I'd like to explore the implications of Mount St. Helens, what it says to you and me personally about our view of ourselves, view of the way the Earth works, and ultimately our view of God. Well, here's the way I remember Mount St. Helens before the eruption: 9,677 feet tall, a very symmetrical profile volcano. It had to be the most gorgeous place on the surface of the Earth. Absolutely beautiful. Spirit Lake there, directly north of the volcano. Just absolutely gorgeous. Here's what it looked like after the eruption. The volcano lost 1,300 feet of summit elevation on the morning of May 18th as 1/2 cubic mile of landslide material, summit and north slope, slid off the top of the mountain. 1/4 of the landslide material, or 1/8 of a cubic mile, slid down into the Spirit Lake Basin, displacing the water of the lake up to 860 feet above the pre-eruption level. That's right, a wave or series of waves went crashing up on the north shore of the lake, 3 football fields high. The lake sloshed back into its new basin with a dam at the southwest corner, showing us this a completely altered terrain. Simultaneously, 3/8 of a cubic mile of landslide material went down to the west, down the Toutle River drainage basin, and blocked that drainage area. The summit and north slope was like a giant cork holding down the volcano, holding down the pressure inside the volcano. As the summit and north slope left on the morning of May 18th, 1980, super hot liquid water inside the volcano flashed to steam, somewhat like a soda pop bottle. You know, when you shake up the bottle with the cap still on the bottle, no fizzing occurs? Well, the same thing, except not carbon dioxide gas, but steam pressure. As the summit left, it released the pressure inside the volcano, and we had this northward directed steam blast equivalent to 20 million tons of TNT blast energy. It did not blow up into the air like volcanoes normally do. It blasted out northward over the landscape, and it leveled 150 square miles of forest in 6 minutes. Enough trees to build 640,000 three-bedroom homes. The northward directed steam blast was one of the most interesting aspects of the 1980 eruption. Here's the old profile, 9,677 feet tall. There's the new profile underneath it, 8,365 feet. It lost 1,300 feet of summit elevation on the morning of May 18th. This would not be the place to be standing on the morning of May 18th. It would ruin your whole day. 1/2 cubic mile of landslide material came directly at us, and then behind that, the steam blast equivalent to 20 million tons of TNT blast energy. Here's the first steam eruption. Remember, it came over the radio in the middle of March 1980. There was an earthquake directly under the mountain, and within a week, it was venting steam. On March 27th, 1980, the steam issued from the top of the volcano. Then erupted volcanic ash, and here you see one of the first volcanic ash eruptions in March and April 1980. Here you see one of the last profile shots taken of Mount St. Helens. On the morning of May 18th, this incredible event occurred. During that 3-month period between the middle of March 1980 and the middle of May 1980, geologists had made a dreadful discovery. the north slope of the volcano was swelling at 3 to 5 feet a day. During the last 3 days, May 15, May 16, and May 17, the geologists were making measurements that indicated that the north slope of the volcano was swelling at up to 50 feet a day. 50 feet a day. It would not be inappropriate to say that geologists knew that something was about to happen. Exactly what was a matter of considerable speculation among geologists. At 8:32 in the morning on May 18th, at 17 seconds after 8:32, there was a Richter magnitude 5.1 earthquake directly under the summit, which dislodged the summit and north slope of the volcano, and we had this enormous landslide, half cubic mile of material in this landslide, and then the steam blast that followed it. It so happens it occurred in broad daylight, not a cloud in the sky, people in airplanes flying over the summit, people on the ground taking pictures of the whole experience. It was one of the most photographically documented transient events of history. It turns out that people were flying over the summit. Here's the summit crater that we saw just before the eruption. Here is the first rock fall evidence in the summit crater, the morning of May 18th. At 8:32, 17 seconds after 8:32, the earthquake energy reached the summit of the mountain. Keith and Dorothy Stoffel in a chartered plane were flying directly over the summit. They were making their third pass. They thought it was their final pass. It was logged to be their final pass. As they flew over the summit, nothing seemed to be happening. And then finally, they saw the rocks falling into the summit crater there at the top of Mount St. Helens at 17 seconds after 8:32 as the earthquake energy reached the summit of the mountain. So happens that Dorothy explained this to me. Dorothy Stoffel explained this to me just recently. She said as she looked down on the north slope of the volcano as the airplane was flying over, they saw something happen that was extraordinary. The whole north slope of the volcano right here began to undulate like the waves of the sea. And then all of a sudden there seemed to be like a zipper opening up from the bottom of the volcano toward the top. The whole north slope began to slide, and then the steam blast came out of the volcano. Here you see the steam blast as it's occurring. The airplane, fortunately, was not flying north over the north slope of the volcano. It was flying from west to east over the north slope. Here we are looking back to the west over the north slope of the volcano. The landslide, the north slope has already slid away, and here's the beginning of the steam blast, equivalent to 20 million tons of TNT blast energy. Not going up, but northward over the landscape. On the ground, a geologist named Keith Ronholm was taking these photographs 10 miles northeast of the volcano. 10 miles northeast of the volcano, a place called Bear Meadows. And Keith Ronholm had these cameras on his tripod, and he clicked this picture. The airplane is up there in the upper left-hand corner, invisible at the 10-mile distance. But here you see the beginning of the steam blast. The landslide has already left and is on the other side of that ridge, that first ridge right there, and the wave is occurring in the lake. Here's the second ridge, and he is standing on the third ridge, northeast of the volcano. One of the next photographs taken, here's the steam blast as it's occurring, the 20 million tons of TNT blast energy issuing out. This is a ground-hugging slurry of volcanic ash and steam. Inside that cloud, it's 550 degrees Fahrenheit, and it's moving at 200 miles per hour there. And it's a hurricane velocity cloud. And inside of there, it's extremely hot. Here's the steam blast cloud coming over the second ridge, approaching Mr. Ronholm where he was taking those photographs. Here it is coming over the second ridge. And this is a ground-hugging cloud of volcanic ash and steam that is toppling the forest as it goes. Right about this time, Mr. Ronholm, who was taking these pictures, made a very important decision. He said to himself, this steam blast cloud seems to be coming directly at me, but not wishing to miss any of this experience and to record for posterity this event, he took this next photograph of the steam blast cloud coming over the top of where he was located. Incredible event happened. That third ridge that he was standing on deflected the momentum of the steam blast cloud up over the top of him. As this next photograph shows, it rose over the top of him. Before it could fall back to the ground and smother him, moving at great speed down this logging road, he was able to get some distance between him and the cloud and even tell the story and trade his slides of the adventure that he experienced. The weather satellite on the morning of May 18th was taking these photographs. This was taken at 9:15, so this would be 43 minutes after the explosion. The weather satellite from 22,000 miles in space took this photograph. And you can see the donut-shaped cloud around Mount St. Helens. That's the atmospheric effects of the 20 million ton TNT equivalent blast energy moving out. The afternoon of May 18th, you see the steam blast, the volcanic eruption all over eastern Washington state. You can see the volcanic ash in the atmosphere, northern Idaho, and even into western Montana. There were very significant volcanic ash clouds given off by Mount St. Helens. This is Yakima, Washington, about noontime on May 18th. It got so dark just a few minutes later that the street lights automatically turned on. It got pitch black at noon underneath the volcanic ash cloud. Then it erupted very violently. For 9 hours, Mount St. Helens built this enormous plume of volcanic ash which stood over the summit. During that 9-hour eruption, the volcano released the energy equivalent of 400 million tons of TNT blast energy. 400 million tons of TNT blast energy is equivalent to 30,000 Hiroshima-sized atomic bombs. Since there's 33,000 seconds in 9 hours, that's the equivalent of an atomic bomb a second. That's the power output of the volcano in full eruption. Yet Mount St. Helens is just a small to average volcano from the standpoint of human experience in history. There have been a lot bigger volcanic eruptions. They came back the day after and it looked like the moon. North of the volcano, the ground was covered with volcanic ash, 500 degrees Fahrenheit. You need special shoes just to walk on the ground surface. Part of the forest north of the volcano. This area was leveled by the steam blast. It took less than a minute for the steam blast cloud to move completely through the field of view. It toppled the forest. It looks like toothpicks strewn around the landscape, but that was a mature forest that was devastated by the blast.
Don't go away.
As a result of the eruption, all were warned or had gone beyond barricades or in areas where there was reason to believe that there was severe geologic hazard. These people died with a warning. And here, the two died here at the camper. Probably the most famous person to die at the volcano was Harry Truman, not the president, but a man of the same name. Harry Truman, 80 years old, lived there at the South Shore Spirit Lake, directly north of the summit of Mount St. Helens. Here he is in his lodge. Before the eruption, the government authorities came to him and said that he needed to leave because it's a very high hazard area. But he refused to heed the warning. He did not leave. He was buried under 100 feet of landslide material, another 100 feet of volcanic ash there at the South Shore Spirit Lake. He did not leave, and there was eminent reason to believe that there was an eruption that was going to occur. This is a late model Pontiac Grand Prix that was located a mile or so toward the volcano on the other side of that ridge from where Mr. Ronholm was taking those photographs. And this car was hit by the force of the steam blast. We believe it's thrown across a road about 200 feet. The top was bashed in. A tree fell across the trunk. Everything rubber or plastic inside, the dashboard, the steering wheel, the seat covers, was vaporized because of the high intense heat. And the tires, they did not burn because they're heat treated. They did not vaporize, but they popped because of the high air pressure, and the paint job didn't come through too well either. Mud flows. On 6 major rivers downstream from Mount St. Helens, we had very severe mud flows. There was more dollar damage from the mud flows than from the steam blast itself. Incredible damage, even far away from the volcano in areas where people thought they would be safe from volcanic eruption. They had these very severe mud flows. This logging camp was overcome by the force of the mud. Very severe mud flows. It looks like a kid's toy box, but that was a real logging camp that the mud came through. Here you see this valley was filled up to this level in mud. 30 feet deep, the mud was flowing through this valley. It scoured the whole valley down to bedrock, and then as the mud flow subsided, it deposited 15 feet of mud. How deep was the mud? Well, you go to the edge of this valley, and you can see the trees along the edge of the valley. You can see the bathtub ring, the mud, how deep the mud got. Can you imagine that, a quarter mile wide of mud flowing through there, 30 feet deep? Very severe hazard and damage from mud flows. The crater itself has been the subject of intense study. And here you see the way the the crater at Mount St. Helens appears these days. You notice we have this enormous mushroom-shaped gob of rock which sits in the neck of the volcano. It's kind of a cork holding down the pressure. It's like toothpaste which is squeezed out of the neck of the tube of toothpaste. Molten material in the neck of the volcano has been squeezing up there and into that dome-like structure, and as it cracks and steams, molten material cools in the cracks and it forms this enormous structure called a lava dome. It's about 1,000 feet high, a couple thousand feet in diameter, and it's the cork holding down the pressure in the neck of the volcano. Here we are looking down on the lava dome. You can see it's a warty type of appearance. That's one of the earlier lava domes. There's been 6 lava domes that have been built up since 1980. That's an earlier one that was kicked out of there by a subsequent volcanic eruption. It has that warty type of appearance. We're looking directly down on the lava dome from above, and you can see hot rock in places can be seen in the cracks of the lava dome itself. Very interesting the way molten material has been injected into those cracks in the lava dome itself. We've been able to go into the lava dome, and it's not the favorite type of tour that you want to take. Here it is, this enormous dome structure, over 30-story tall building in height. It continues to steam and crack. There were no lava flows from the recent eruptions of Mount St. Helens, just dome building and dome cracking events as molten material was injected into the structure itself. The lake north of Mount St. Helens, Spirit Lake, has been devastated by that landslide debris that went in the lake. Here we are looking at the lake. It might appear like it's a beach with logs on it, but that's a lake. That's lake water. You can see water between the logs in the lake, and this is the area of the lake. About 4 square mile area lake, about 2 square miles of it's covered with logs. It's been estimated there was originally about 1 million logs floating in the lake after the eruption. This log mat drifts around. Here you see some of the details of the logs in the water from up above by helicopter. Incredible thing about this log mat is it drifts around. Here you see the log mat, and on one morning I came and photographed it. Notice the peninsula and the cove in this lake. I came back 2 hours later after the wind had shifted, and you can see what happened. The wind blew the logs back to the south in toward the crater, and here you see the peninsula, and there's the cove, and the logs are all over this area. The water is alternately covered with logs as the wind blows the logs around through the lake. Here's the north end of the lake right here. It's a very log-covered area, and you can see here where the wave went. There was a wave 860 feet high, a wave or series of waves 3 football fields high, went crashing up onto that area, and it scoured it of logs, and the logs landed back in the lake. That's where the trees came from that form the log mat these days on Spirit Lake. In the middle of the picture here, this bench was scoured by the wave that came up here in a giant vortex. The foreground was not scoured by the wave, just hit by the blast.